Hello everyone, welcome to Academic Coordinates. In this video, we're going to be determining an unknown sample that consists of carbon, hydrogen, and oxygen, right? This unknown sample reacts with oxygen in excess to produce X moles of carbon dioxide and Y over 2 moles of water, right? So, obviously this sample consists of carbon, hydrogen, and oxygen. So we are actually going to be calculating the percentage composition in this combustion reaction. So I'm going to be using the technique of dimensional analysis. There are other ways, that you can do this. Okay, initially, I am going to calculate the mass in grams of carbon in the original sample, right? So this is I'm going to start with 23.26 grams of carbon dioxide, right? So remember, I'm using dimensional analysis. So 1 mole of carbon dioxide per 44.01 grams of carbon dioxide, right? Okay, so obviously, for those who are wondering how I got the 44, so carbon contributes 12.01 and oxygen contributes 16.00. So 16.00 times 2 plus 12.01. Let me actually redo that. So that is 32 plus 12.01. Then there you have it, 44.01. 44.01. Okay, so I'm going to be using dimensional analysis in this form to actually solve this clearly. Okay, cool. So from this, right, we are going to be multiplying by the molar ratio. Right. So if you can look at this combustion reaction, for every X moles of carbon dioxide, you've got 1 mole of CX, HY, and OZ, right? Okay, we're going to multiply this by, so for every 1 mole of CXHYOZ, you've got X moles of carbon, right? Then I'm going to multiply this with, for 1 mole of carbon, there are 12.01 grams of carbon. So let me explain this if you guys are a bit confused with this technique. So dimensional analysis, it's sort of going to cancel out the units until you get the unit of interest. So you see the grams of carbon dioxide cancels with the grams of carbon dioxide. The moles of carbon dioxide will cancel here. This and this, this and this, right? And then our final units will be the mass there in grams. Okay, so let me just explain this. So 23.26 grams of carbon dioxide. So I had to change this into the moles, or the amount in moles of carbon dioxide up to with this calculation here. Then from here, I took the moles of carbon dioxide to the moles of our sample there by relating the molar ratio. So there is 1 mole of CXHYOZ per X moles of carbon dioxide. That is what you're seeing here. And then over here, there are X moles of carbon in this portion. Now there are X moles of carbon per 1 mole of our sample. And then up to this point, we're going to get the moles of carbon in the original sample. And then we had to now take that into mass. Then this is I multiply them with this ratio of 1 mole of carbon per 12.01 grams of carbon. So if you actually calculate that, you are going to get a value of 6.347 grams of carbon. Then now, this is the carbon in the original sample, right? And then we're going to do the same with hydrogen. So the mass in grams, of hydrogen, this equals to, okay, just one thing to take note, that this x, this x and this x, we're going to cancel each other. So we're not going to have unknowns. This is the final answer that we're going to have. Okay, cool. So now, the mass of hydrogen in the original sample, we start with 9.52 grams of water multiplied by, okay, so 18.0, this is 18.02 grams of water. So you can actually calculate that. So this is the molar mass of water over here. We are going to multiply that. So up to this point, we're going to get the moles of water, right? And so for every Y over 2 moles of H2O, there is 1 mole of CXHYOZ, right? And then just, be conscious of what is going to happen with that Y over 2, or that Y rather. Then multiplied by, for every 1 mole of our sample CXHYOZ, there are Y moles of hydrogen. Then there is it. For every 1 mole of this, there are Y moles of oxygen. So that is how I related the two over there, right? And then I multiply that finally now with the molar mass of hydrogen. So hydrogen is 1.008 grams. Okay, then obviously also here you are going to, these units will cancel each other. This one with this one, this one with this one, this one with this one, until you are left with the units of interest, right? And so if you do that calculation, you will get 1 point, let me write that in green, you will get 1.065 grams of hydrogen. These are the grams of hydrogen in the original sample, right? And do take note that this Y will cancel with this one over here. So you will actually get this point at this point. Okay, so at this point, guys, I want us to take note that we need to also determine the mass of the oxygen in the original sample. However, we're going to do that using the percentage composition. All right, so we know that this sample C X H Y O Z, we've been given that it's 9.83 grams of this sample. So we are going to be determining the percentage composition of carbon from this 9.83, right? Okay, let me continue using white. Okay, so for carbon, we got 6.347 0.8347 grams of carbon. So we're going to divide here with 9.83 grams of this sample, right? Then we're going to multiply that with 100, Okay, so after we have done that, we'll take note that we get 64.567% of carbon. We do the same with hydrogen, right? The percentage composition of hydrogen. Obviously here we got 1.065 grams of this hydrogen divided by 9.83 grams of the sample that we have multiplied by 100%. Then from this one we are going to get 10.834% of hydrogen. Okay, having found this, we know that our sample consists of carbon and hydrogen and oxygen. So basically, the remaining amount will be for oxygen, right? So this carbon and this hydrogen consist, or its composition is 64.567 plus 10.834. So carbon and hydrogen renders 64.567 plus 10.834. So both of these are 75.401, right, percent. So obviously for oxygen now, the percentage composition of oxygen will be 100% minus 75.401%, and then we are going to get 100 minus 75.1, then we are going to get 24.599%. So there is our sample. Carbon, it's 64.567%. Hydrogen is 10.834%, and oxygen is 24.599%. Then at this point, we assume 100 grams. We assume 100 grams. So what this means is that we are going to have 64.567 grams of carbon, 10.834 grams of hydrogen, and 24.599 grams of oxygen, right? Then we calculate the molar mass, the number of moles of each of these, right? So the amount in moles of carbon equals to 64.567 grams of carbon multiplied by its molar mass, 1 mole of carbon, 12.01 grams of carbon. So you see, guys, this is still dimensional analysis. Then from this, what do we get? We get, let me write it in white, 5.376 moles of carbon. Then the amount in moles of hydrogen. Then for this one, we've got 10.834 5.834 grams of hydrogen multiplied by its molar mass. 1 mole of hydrogen per 1,008 grams of hydrogen. Still, guys, dimensional analysis. Okay, and then what do we get? Here, we are gonna get 10.748, right? Okay, cool. So let me just do that again. So it's 10.834 divided by 1.008. So 10.748. Okay, cool. That is moles of hydrogen. So we're almost done, guys. The amount in moles of oxygen. This is for oxygen we've got 24.599 grams of oxygen times its molar mass. 1 mole of oxygen, 16.00 grams of oxygen. So this and this cancel, and then we are going to have 1.537 grams of oxygen. Okay, guys. So now let us write our sample. So it's C is what is this? 5.376 moles. Hydrogen is 10.748 moles, and oxygen is 1.537 moles. All right, then we're gonna divide. We're gonna divide all of these moles with the smallest number of moles. Obviously, this is this one over here. Okay, so obviously, see there. So it's 5.376 divided by 1.537. Then we have 3.498. I rounded that off. Then H over there. When I make this division, it's going to be 7.049. And then obviously oxygen will be 1. So now I've got decimals here. So let me just multiply by 2 to simplify this. So this is going to be C7H14O2, right? So this is the approximated value. It's almost 7, it's almost 14, then this is 2. Then voila, this is our sample. Then you are also told that it's C7H14O2. All right, guys, I think that's about it now. To stay blessed, enjoy the rest of your day. Yes, and also, if you've got any questions, do let me know. I know this was quite long, but yeah, do stay blessed.